we're doing today is simulating a mission with a crew, in a capsule, basically parked on the far side of the moon, with the rover on the far side of the moon deploying an antenna on the surface of the moon. So in this type of situation where you don't have communication with the MCC, and the crew is responsible for driving the rover. So contrast with like how they operate Curiosity, where that's under control from the control center. Okay. In this case, the astronaut has control over the rover. And up on the big screens there, on the left-hand side is a kind of an engineering display of what the rover is doing. So it's got a virtual model of the rover in its virtual environment. So it's kind of similar to what the crew sees on their user interface. When we come back, we get our signal back in hopefully in about 5 minutes. The right-hand side it's a camcorder view from within the ISS, and it's pointed at the user interface that the crew is using, so you'll be able to see what the crew sees. So basically, he'll be using his interface to control the rover to deploy an antenna. Excuse me? It's Luca. So our operations lead is in the black with her back to us. This experiment on ISS is being conducted as a payload activity. So all of our interaction goes through Marshall Space Flight Center. They're in charge of payload activities. Johnson Space Center in Houston is in charge of basically operating the vehicle, ISS. But Marshall is in charge of all of the experiments. So our operations lead is talking over her headset to folks at Marshall, and they talk to the crew.
I've emailed you
And then she's also talking to our engineering team, which is over at the Roverscape, which is where the rover facility is, just a few blocks from here. And so okay, yeah, so you'll see a little fake moon that we have outside.
He's got the questionnaire, so we'll just
Where does the signal come in?
So starting with the rover, the signals, so the sensor telemetry, the video from the rover, we've got it, a secure Wi-Fi network out at the Roverscape, which goes onto the mission network from here to Johnson Space Center. From Johnson Space Center, it goes on a landline to White Sands, New Mexico, which is where all of our NASA's ground-based antennas are. And that's, so that goes up to a satellite that's in geosynchronous orbit, very, very far out in space. And that goes from the satellite back down to space station. So that's about a 2 to 4 second trip.
And then back when they send a signal.
Yeah. And that's other than the part then coming out to Ames, but from MCC to space station, that's the typical path that all the communication goes. But by using those satellites that are in geosynchronous orbit, that's what gives us pretty much around-the-clock coverage, constant communication with the space station. Whereas if you're doing direct from the space station to the ground, you would only have that communication available as the space station is flying directly over your antenna. Right. So actually, Luca completed his training right before you guys got here. So the training consisted of him looking at some reading material and then just playing with the rover to get accustomed to the user interface. So we know that the communication link is working. Okay. So in about 15 minutes, we're going to have a crew conference with him just to see if he had any questions and just kind of go over again the mission that he's conducting today. So right after that, we'll start the mission, and our objective is for him to deploy one of the 3 antennas. But ideally, he'll go through all 3. Yeah, and so the way we do this is he has basically scripts that the rover executes, and he uploads a script and then tells the rover to do it, and then he monitors the progress of the rover. So the script would be something like drive here, start deploying the antenna, and it just leads the rover along the mission that we want it to execute. So that's something we've already pre-programmed. He monitors to make sure that it's deploying correctly, to make sure that there's no tears in the antenna as it deploys, to make sure that if the rover gets stuck by an obstacle, he can take over and manually drive around the obstacle and tell it to resume the script. So it's really, he's really like a supervisor of the rover operations. So there's a lot of autonomy built into the rover itself.
That's good. So he can play around with it.
Yeah, and so we've perhaps put some rocks in the way to make him take over as part of the simulation.
He has to
Yes.
do some, okay, to
Yeah.
make sure that they can. And this, have they done this before? I'm thinking I've only seen this one time.
Yeah, so we did this June, I think, 17th with Chris Cassidy,
Oh, right, okay.
and it was a very successful test. So.
I read about that on NASA.
Was there anything unexpected last time it was done?
You know, I mean, right at the very end, we had an out of simulation problem where the rover actually had a failure, but it was right at the end, so it kind of worked out. They were just able to stop and go take a look at the failure. But so that was the only out of sim unexpected problem. We had a lot of in sim problems that we caused for Chris to deal with, like low battery readings, just to see if he had situational awareness of the things that were coming up on his user interface. Like I said, we had some scripts that had the rover drive towards rocks to make him stop the rover and take over with manual control and drive around it. And he handled them all well, though.